Ever wonder how AI models like GPT-4 can solve a brand new task just by seeing a few examples? It's like watching a kid learn to play a game by observing others. No instructions, just pattern recognition. This is in-context learning, and it's one of the most fascinating tricks in modern AI. But here's the real question. How do these models figure out the rules just by looking at examples? And why do they often pick the simplest explanation, even when a more complicated one is possible? Let's break it down. Imagine you're trying to guess the next word in a sentence. If the sentence is "the cat sat on the mat," your brain probably expects something like floor or rug. But if the sentence is a math problem like 2, 4, 6, you'd guess 8. Both are patterns, but one feels more natural. Transformers do something similar, but with a surprising twist. They prefer simpler explanations, even when the data could fit a more complex rule. This isn't just guesswork. It's a deep bias towards simplicity, like a built-in Occam's razor. Think of it like a detective solving a mystery. If a suspect's alibi fits the evidence perfectly, why complicate things with a more elaborate theory? Researchers tested this by feeding models sequences of data, generated by both simple and complex rules. For example, a simple rule might create a pattern like A, B, while a complex one could make A, B, C, A, B, C. When given ambiguous data that could fit either, the models consistently chose the simple one. To study this, scientists used two setups: Markov chains and linear regression. A Markov chain is like a chain where each link only depends on the one before it. Think of predicting the next letter in a word based on the previous one. Linear regression is like drawing a straight line through scattered data points. The models were shown sequences from both simple and complex rules. The key question: would they pick the simplest explanation when given a choice? The answer: yes. Transformers didn't just memorize the examples, they reasoned about the underlying structure. This suggests they're not just pattern matchers. They're building a kind of statistical intuition, weighing how well a rule fits the data against how complicated it is. But how does this play out in real models? The researchers tested GPT-4 with tasks where both simple and complex solutions were possible. For instance, they asked it to predict a sequence by either copying the first element or taking a majority vote. Guess what? GPT-4 chose the simple solution every time. It's like the AI version of Keep It Simple, Stupid, but with way more data. So why does this matter? It shows that transformers aren't just mimicking human reasoning. They're internalizing principles of efficiency and parsimony. This bias toward simplicity might explain why they excel at tasks requiring generalization, like language understanding or logical reasoning. But it also raises questions. What happens when the real-world data defies simplicity? How do models balance this instinct with the need to adapt? Now let's zoom out. How do these models actually process context? Researchers discovered that longer context windows, the amount of input a model can process at once, significantly improved performance. Imagine a student who can review 10 past problems instead of just one. They'd solve new ones faster, right? That's exactly what's happening here. The more context a model has, the better it becomes at spotting patterns and making predictions. But it's not just about length, it's also about size. Bigger models with more layers and more attention heads, think of them as tiny detectives scanning data, outperformed smaller ones. It's like comparing a solo musician to a full band. The bigger team can handle more complex songs. And here's the kicker. Transformers didn't just match older models like LSTMs. They surpassed them, especially at tasks like probabilistic grammar and Markov chains. It's like upgrading from a flip phone to a smartphone. Now let's talk about how they adapt. Earlier research showed that in simple grammar tasks, certain probabilities vanish. Like if two rules are equally likely, the model might ignore one. But here's the twist. Transformers don't just follow rules, they learn them. They use in-context clues to figure out the best way to handle patterns, even if those patterns get tricky. It's like a chef tasting a dish and adjusting the recipe on the fly instead of sticking to a rigid formula. What about when models are trained on only complex tasks? Here's where it gets wild. They don't automatically switch to simpler solutions, even when those solutions are better. Imagine a math student who's only practiced advanced calculus. They might struggle to solve a basic arithmetic problem, even if it's easier. This shows that models need explicit guidance to learn the easy way, just like us. And here's a game changer. When models have limited context, like fewer clues, they still pick the right pattern just with less confidence. It's like solving a mystery with only a few hints. You'll get the answer, but you'll second-guess yourself. But when given more info, they nail it. So what's the takeaway? Transformers aren't just powerful. They're adaptive, efficient, and way better at learning from context than older models. This research isn't just about AI. It's about how we design systems that can handle complexity, adapt to new challenges, and even think like humans. Thanks for watching. If you're curious about how these models really work, hit subscribe for more deep dives into the science behind AI. And let me know in the comments, do you think AI will one day learn as flexibly as we do? See you next time.